come on up and let's welcome our first panel. Thank you.
We'll go around. JoeBen, like I reminded him that I met him at Santa Cruz about, it was 8 years ago, just about. There was an FAA conference where he went up stage and said, we're going to completely change aviation. Everything's going to be electric. The sky's going to be full. And you could just see the FAA people hiding under chairs. But it was fantastic because he actually did it. It's like the airplane is flying right around this neighborhood, I think, right? It's
yeah, so we about 1,000 feet that way in the forest, we in a barn, we started JoeBen Aviation in about 13 years ago. So
that's very cool. That's exciting.
There's a special story about Howard's Pond last year when we were fighting the wildfires. That pond saved, if you look at the map of the CZU fire, there's this pocket cut out of it, and that's because of Howard's Pond.
Yeah. Next we have Sara. Sara is sort of senior VP, I think, is New Vista. New Vista is an evergreen SPAC and late stage investment. Am I saying it correct? Investment. I'm also an advisor there. That's how I know her. And her dubious sort of history is trying to convince Boeing to be innovative. And she was a sort of director of advanced projects at Horizon X. So anytime you have one of the world's most amazing companies, Boeing, but then you're trying to convince them to invent themselves, that has to be completely crazy. I'd love to know about this. Omer is the CEO and co-founder of Aviation. They built a beautiful airplane called the Alice. I had the opportunity to go crawl all around it over the last, I think, year. It's if you love clean designs, carbon fiber, they're amazing. So you have a really interesting sort of collection of sort of probably the most advanced eVTOL, probably the most advanced conventional wing commuter, probably the most advanced thinking about what will a large aerospace company plus investment will do. My claim to fame is I started the Amazon Prime Air project about 9 years ago at this point, ran it until it moved into operations, got the air carrier certificate, went into the G2 stage of type certification, product certification, and since then I'm doing some other things. I won't put your time. What I wanted to start this panel is with a premise. The premise is that a lot of these companies, especially these two companies, and a lot of the organization that Sara is helping and saying, will get type certified. That's not a question anymore. It's just a matter of when. Yes, I know the FAA is going to take longer. Yes, may have better rules. Who knows, right? But the reality is, over the next 2 to 5 years, at least these two airplanes absolutely will get type certified. They will be flying. They'll be manufactured. They'll be in air. I know some other people will get type certified. See over there. But so that's sort of a given. What's interesting for me is a lot of aerospace programs don't fail in type certification. They fail when they go into service. So probably the classic example is the Lockheed L1011. People remember it failed in supply chain because Rolls-Royce, one of the world's best companies, failed to produce the engine. Right? The program was about 2 years late, and at that point, the market was over. And that was one of the best airplanes of its time. That airplane did the first takeoff to landing fully autonomous flight in the late 80s, fly-by-wire. So you're talking about really unique technology, and they failed in the market. You have programs like this Beach Starship, right? Fantastic airplane, if you ever seen flight, failed in the market. So there's this topic around, great, you've managed to type certify, you even managed to produce it. Now what? How do you actually make it a good business? I'll maybe throw in 2 metrics that I care about, and then we'll ask the panel to sort of chat about it. One metric that I really care about is dispatch reliability. Can an airplane fly when it needs to fly, when a customer expects it to fly? And the second one is fleet productivity. How often is the fleet on the ground versus in the air? Airplane either make money or cost money. If they're on the ground, they cost a lot of money. If they're in the air, they potentially can make a lot of money. So that ratio is absolutely critical. So again, the first one irritates your customers if you're not available. The second one irritates your shareholder if you're not flying enough. So the key question, I guess, is how do you think about this? Like, are these the most important 2 important metrics? Are there other metrics you care about that will make or break your program, and will sort of go closest to furthest, I guess? Start with
thanks. First of all, it's kind of, I didn't know it was going to be the scary part of this, but yeah, this is definitely the scary part of what we're doing going forward. But I think at least I speak to myself, when people ask you as either as a founder or as kind of in the leadership of a company trying to do something that different, what keeps you up at night? The answer is everything. And yes, of course, this is also a problem, but there are so many others, right? So the question is, where is your focus at any given moment? And what I love about the two topics you brought forward is that you have to have those front and center from day one. It's an integral part of the way you design. And for us, that was part of the reasons we went through significant design changes over the years. It was part of the reason we went into partnerships with people we trust. Now, I think in terms of dispatchability, that is a huge deal for us. I think in theory, a plane that is as simple as what we're building, it's a huge battery with 2 motors, fewer moving parts, nothing goes to 900 degrees F or C, you choose your poison, nothing goes anywhere near that. And again, in theory, that's a system of great simplicity. So we should see higher dispatch reliability. The other side of this is that when you do something for the aerospace industry, your selection of components really is limited and is very different than what people kind of envision. Oh, there are very, very safe and reliable inverters. Yes, to the auto industry. How do you bring them to the market? How do you put them in the air? And how do you kind of really reap the rewards of that potential dispatchability, reliability? And the answer is, well, we don't know yet. We're working on it. And a lot of it is in development. So it's true that in theory, it should be better. And it's the job of the design company, the OEM, to make sure that we actually reap those rewards. When we look at our plane today, our target is to achieve higher dispatchability. I mean, the 99.9 something% is where we go, because we're a commuter aircraft. We're going to sell it to companies that lose money if they don't fly anywhere between 1,500 and 2,000 hours a year. That's plenty. I'm guessing JoeBen's numbers are a bit different, but still, these matrices are painful. So we're on it.
Excellent. So there's always this balance between the lesson you've learned in Boeing and what you're trying to help the industry do. Sort of, are these the right metrics, or there are other metrics that people should think about?
I think I won't answer the metrics question specifically, but on this topic of how do we ensure that if a passenger wants to go somewhere, we can actually make it happen. And so it was funny because I was actually meeting with Uma, who started Boom, and we were talking about business models, and now she's running Aero, which is fully integrated, and how the business model is important. So when we think about, and since we're talking about decarbonization, with the mission lengths that we'll see, we're really talking about urban and regional right now. And so when we think about what are the right business models to ensure that we can get someone from point A to point B, through kind of the in-market work I did with Boeing, which was actually very informative. I launched an urban air mobility pilot using today's helicopters as proxy to understand what were really the challenges. And one of the big learnings we also did a regional on-demand in-market test as well. And the difference in dispatch reliability, not just from the technical or maintenance perspective, but from thinking about things like crew availability, weather, other things like that. There was a huge difference in your ability to control what you could control, but there's so much outside of what you can actually control. And so that vertically integrated, from everything from, owning the aircraft, the asset heavy model actually works much better in terms of being able to deliver service at the end of the day to a passenger. And so it's interesting as we talk about different business models. That's something that I am keeping an eye on when I'm talking with startups, is what is that business model that you're pursuing? It can't just be about the aircraft, because ultimately what we're trying to do is get someone from point A to point B, and the value proposition is more convenient and faster. So how are we going to deliver on that? So for me, I spent a lot of time thinking about those business models,
So that's a fantastic segue, because I always felt that my system at Prime Air was vertically integrated. But JoeBen, I don't think there's anything you guys don't build directly.
We didn't coordinate on this, by the way.
I know.
I was thinking that was just you were teeing me up in a bit of a way. Yeah, I mean, we've definitely chosen a very vertically integrated business model. We build our own power electronics and battery modules and carbon fiber and everything, but that's not our business. Our business is to move passengers from point A to point B, right? And so that gets back to your point about dispatch reliability and the productivity of the aircraft and how many hours per year can we fly it. But it's even more than that. It's about pilots, and it's about how many cycles we can get off our battery packs, and it's about the reliability of the motors and how much service that we have to put in. So if you look at operating an airline today, there's the crew costs, there's the maintenance costs, there's the fuel costs, there's the depreciation, there's the interest on the aircraft, all those different pieces. And we have to look at when you're flying a block time that is minutes instead of hours, how do you get those, how do you get utilizations that are thousands of hours per year, such that you get your depreciation and interest costs down. And the beautiful thing about aircraft is they fly really fast, right? So aviation is amazing because it's our fastest, safest, and most affordable mode of transportation. I mean, it's staggering. It's like multiple orders of magnitude safer per passenger mile traveled than anything else we've got. It's also multiple times lower cost, and it's 10 times faster. You look at that and you go, how is that possible? That's amazing. It's a total game changer. How do we bring this utility to daily mobility? How do we move, free us from, driving around for the vast majority of our daily trips, or vast majority of our trips, and period. So we think that's really exciting. And then the beautiful side effect is that by doing that, now all of a sudden you've decarbonized daily mobility.
Yeah.
So
maybe that good segue. Thank you. I swear I didn't pay anything for this, but that gets to sort of a fundamental economic question where a lot of companies already started to announce ticket prices or seat mile type economics, and there seems to be a little bit of a race to the bottom because
Why a little bit?
Well, okay, there seems to be a crazy race to the bottom. Everyone's saying our ticket price is going to be cheaper per, for this specific leg and this specific location than anyone else. Sort of feels premature because we don't really know what the total cost of ownership of these assets will be, or the willingness for payment. And we know that in the beginning, that let's say 10 years from now, maybe we can fly 1% of the population that actually wants to be flown. Just it's going to take time until this infrastructure is built. So it's sort of surprising to me that we're already talking about pricing. I mean, in a way, when I think about it, I think it's safer and cheaper and more accessible than a helicopter. I don't think it's a faster Uber Black, right? But maybe I'm wrong, right? How do you guys think about it?
I think it really depends. I think JoeBen is doing something fundamentally different than what we're doing, in the sense that it's a new twist on an old problem. You want to move people in and out of cities or within cities in a way that's different, and it's actually creating a means of transport that the helicopter did not serve. And it did not serve it because it's expensive, it's noisy,
It's not safe.
It's not an aircraft, it's a bunch of aircraft parts flying information. But that said, that's something that requires that kind of vertical integration. And I think the effort that JoeBen is leading is fundamentally different there and phenomenal. But I think if you do look at trying to replace existing market, like what we're doing, we're building a plane. It's a plane. It takes off from a runway. You use a pilot to fly it. You land it when you're done. And instead of fueling, you're charging. And we even figured out charging in a way that doesn't take longer. So just get it done, right? The business model is there. We can give you a price for it. And I think the fundamental difference is that if you try to say, I don't know the price tag yet for something that is visible in the market and is kind of a head-on replacement to what's going on today, you're going to get in trouble, because the aviation industry doesn't care. It's amazing, it's fast, but it doesn't care about anything but direct operating costs. That's the driving force. Like, can I do this for a price tag? We could have flown supersonic. We did for a while. We could have flown in very different ways, but we're not, because it doesn't work. And the question is, does electrification, decarbonization, whatever you want to call it, does it work financially? And for us, the answer is yes, and we have to put a price tag on it because we have customers who are now, putting in down payments, and they want to figure out, is the machine, for the client, for the airline. No offense, I love airlines; they're my clients and they're the best. But at the end, that's their factory. They sell seats in the air, and they need a price tag for that so they can do their math. And I think that's really the heart of any innovation that any OEM can make. It's like, where's your business? I think it will usher in. And again, if it works financially, it will usher in faster than people think, other modes of transport. And obviously, when JoeBen kind of builds up the network there, it will just all mash together because it works financially, and there is someone decarbonizing and quickly bringing the passengers in to. So it's all a matter of where are you in the market.
So, Sara, you get to speak to hundreds, if not thousands, of startups, late stage, early stage, that are sort of struggling for these challenges. Sort of, are they working backwards from the customer and market requirements? It could be the end customer, or can be the airline, depending on the go-to-market strategy. Or are they working forward from a technology and decarbonization strategy? And is there like I think you have to do both, but what is less wrong, I guess?
Less wrong, in my opinion, or what's happening? I think you.
Well, I think both, right? I actually want your opinion, but also your sort of perspective.
What I see is most people working from the technology perspective and then trying to back into a use case and a value proposition for the end customer, which I don't think is quite the way to go about it. At the end of the day, when I think about aviation and the behavior of end users or passengers within the system, it is highly commoditized. And so I think it's hard to restructure people's decision-making processes. It's schedule and it's cost, and that's how people make decisions. And we've seen that billions of times. And so when you talk about introducing new aircraft and creating new networks or systems, I think we have to assume that some of the decision-making framework will be very similar. So if you can't really differentiate on costs, because there's going to be some kind of baseline that's created for the segment, then you need to be able to differentiate on service. And so when I think about whether it's regional or urban, because we're talking about decarbonization, it's really important to think about the entire journey. So from door to door, what is that experience going to be like, and how are you going to differentiate on service, which in my mind is the main value proposition is time and convenience. And so the people that will come out ahead are the ones that figure out how to solve the whole problem for the consumer, for the passenger, which is getting myself from door to door, right? And so I start to think more about what kind of, if you're not going to be the one that creates the network, who are you working with to create the network? What is your footprint going to be like? And can you achieve the route density, whether it's scheduled or on demand, to be able to offer the type of frequency that someone would want to see? And, I think there's a lot of mental shaping that's happened from other transportation systems. If you think about the best transportation systems, either urban or regionally, you can think about some of the train systems in Europe. At the end of the day, someone doesn't, the best systems are the one where you can leave your front door and walk 5 minutes to whether it's a train station or in the future, a vertiport, right? And so what does that network look like, and how do you deliver on that service? And I think those are the things that really matter in thinking through what is it going to look like at the end of the day, and how do we actually drive demand and scale for this? Because if you just think about the aircraft, at some point, no offense, you two, there's going to be some commoditization of the aircraft platform itself. And the differentiation from the platforms or between the platforms are not going to be that great in the end user's mind. So it really becomes about service and service delivery.
I have to wholeheartedly agree on all of your points. I think coming back to your question about the price, when I sat down to think about this, well, originally back, this is a childhood dream of mine that I then worked on in the early 90s. At that point in time, our batteries, we were running nickel metal hydride cells, lithium-ion. Sony hadn't released the first lithium-ion cells, and their first lithium-ion cells didn't have the specific power that we needed. So at that point in time, we had specific energy in like the 40 to 50 watt-hour a kilogram range, and specific power of a few hundred watts per kilogram. My view was we needed specific energy of north of 200 watt-hours a kilogram and specific power of over 1,000 watts a kilogram. So came back to it in the mid 2000s, and at that point in time, batteries had improved materially. You could start to build a useful case around it, but you have to really think about how does this become something that's not just a niche mode of transportation? How do we build something that really fundamentally changes people's daily lives? And that's really, to me, about the cost. And it's one of the reasons that I've been trying to drive the industry to the bottom. We've got Blade, which offers helicopter service to very affluent folks at between $10 and $20 a passenger mile. The other end, you've got commercial airlines, which are providing service at 10 to 20 cents per passenger mile. My 2005 Prius, after I bought it, it was relatively new and it was getting depreciated, was about 50 cents a passenger mile. Now it probably cost me 30 cents a passenger mile because it's fully depreciated. My Tesla Model S, when I first bought it, given depreciation, was at about $2 a mile. And now it's probably down around $1 a mile because it's fully depreciated. And then you look at a taxi at like maybe $4 a mile. And that's the pricing continuum that I think about. So I said, if we're going to build something that's really broadly accessible, we need to start in like the $3 to $4 range. And in order for it to be something that lots and lots of people are able to use, it needs to get down to below $1. And that's why I've been just really religious about how do we drive down the price. And it's really it's about looking at every cost center and how do we diminish that over time? How do we make the aircraft more reliable? How do we make it more productive? How do we make it more autonomous over time? So these are all areas which and the market, the demand is massive if you can get the price point where it needs to be, and you can make it walkable, as Sara was talking about. Making this, it's really about the service, and the service is really about the infrastructure. And how do we make, there's huge synergies for the real estate market, right? I had a floor of a building that I was leasing, and they put in a new subway stop in the basement. Within a year, the rents had doubled. There's a huge value to connectivity when it comes to real estate. Buildings that are close to highway off-ramps have more value. Those that are close to train stations have more value. And so this is all of a sudden, if you build a skyport on your roof, your asset has the cap rate is substantially better. So it's really an exciting new disruptor to global real estate.
Very cool. Maybe I'll do one more question and we'll open it up in a way. I know there's some microphones though. Everybody here has I think about decarbonization as a theme, but it's clearly that there's a lot of sort of focus in the US around battery electric and more so in Europe around hydrogen, especially for longer range and sort of larger aircraft. My personal perspective is there's no right answer. If you want to fly 1,000 miles, you're going to have to do something that's hydrogen-ish. And if you want to fly 200 miles, batteries work great and they offer amazing simplicity. But there does seem to be this little competitive spirit within everybody who's doing decarbonization, where I think we have a common enemy, and that's the internal combustion engine. And then we should all focus against that.
Unless if it burns hydrogen.
Unless it burns hydrogen, right? I mean, there are hydrogen engines. I think motors and engines are functionally equivalent as long as they're decarbonized, I think. But there seems to be this really interesting tension between people who are hydrogen advocates against battery and people who are people who are battery advocates against hydrogen. And that doesn't make sense to me because they don't really solve the same application. And you guys sort of represent, I guess two of you represent the battery contingency, if you will. Is that an interesting argument, or are we just sort of following politics in a way? The other side, I think, is that there are a lot of incentives in Europe to build hydrogen infrastructure. And is that really the reason, right? And now we have a new infrastructure bill. Is that going to be sort of mutating the market in some interesting way? Because there are sort of monetary and government programs that help us do decarbonization in specific ways, which may not be the best technologies, but they actually, offer easier path to funding.
You want to?
I'd love to. So I'm a huge fan of hydrogen electric, but that's an important distinction. I actually think that if you burn hydrogen, it's nearly as bad as burning other fuels. If you look at, we're talking about decarbonization. To me, actually, that's not what we need to be talking about. What we need to be talking about is climate change. And carbon is only a third of the climate change problem from aviation. The other 2/3 is contrails. This is NOx, SOx, soot, and fine particulates, and most importantly, water vapor in the upper atmosphere, driving radiative forcing. And so the key thing is, if like I've flown millions of miles, every time I get on an airplane, I feel incredibly guilty. It's horrific climate consequences. And yet I love to be able to engage with people face to face. And so, I fly a lot. I want to build, I want to see the world. We have the technology today to build true zero emissions aircraft, long haul aircraft. And, one of the things I've been really pushing is Airbus and Boeing and all the other global aviation companies. We need to get up and we need to be ambitious. We need to say, let's solve this problem. Let's deliver aircraft that really end the climate consequences of aviation, not just for battery electric few 100-mile flights, but all flights. And so I think the work that Europe's doing, the leadership that Europe's shown is absolutely on hydrogen is absolutely spectacular. But it is crucial that we do not burn hydrogen, because burning hydrogen has horrible climate consequences. You can't put that water vapor into the upper atmosphere.
There was a reason I wanted you to start. I agree with the big picture claim. We need to be bold. We need to build a true. I hate the word net zero because it means someone planted a tree somewhere. I think we need to build zero emissions machines, and that's important. And I agree, emissions go hand in hand with emissions means all emissions. By the way, noise as well. The whole thing needs to be better. I think there are two things that are very problematic. And I'm saying this because I'm building a fixed wing and I'm thinking bigger and what's next. And there's more cream up in that market. But I'm not sure hydrogen is the solution. I agree that burning hydrogen is bad. It's not as bad, but it's bad. And there are some very fundamental, no-goes. We are more or less in the nickel metal hydride stage of hydrogen, and it's very painful. And another angle of this is how do we make that hydrogen and how do we move it around, which again goes to emissions and goes to price. And my belief there, kind of reflecting back on your question, is that we have a tendency as regulators, as governments, especially in Europe, as kind of the people trying to fix it, to say, oh, there is a new thing, now it's hydrogen, or it was hydrogen for a while, but let's throw some subsidies in it, and let's make the people burning real fuel pay for the people burning SAF. Let's invest $1 billion into batteries, and then I kind of anecdotally, I had a meeting with a few investors quite a few years ago, and they told me in a beautiful chart how battery technology is going to be great, because now we're at roughly 250 watt-hour per kilogram, but in 5 years we're going to be at 400, and in 10 years we're going to be at 500, and everything is fine because we have a chart. And I looked for, so when I was kind of a very young engineer, I was I was working for an auto industry company, and I literally found a slide from 2004 that had the exact same numbers. Hey, we're here, and don't worry, in 5 years, it's fine. Now, hydrogen's been the promise of the next 5 years for the last 15. And there are reasons for that. It's not just a hard problem. It also creates a lot of new problems. And I think what's important for government is to be an enabler, kind of fund the result. Don't fund a technology you just heard of. So I'm not sure, I actually am not a big believer in fuel cells as they're built today. I think we have a lot of issues. Putting them on a plane, as you know, is, putting anything on a plane is not trivial, right? So a fuel cell is even worse. But I think what we need to see is we need to see the bold move. And that goes back to you and to companies like Boeing and Airbus. I think declarations are great, but I haven't seen, I'll say it the other way around. Show me an Airbus executive or a Boeing executive that has the balls right now to say, you know what, I'm going to build another A380 or another 787, another gas guzzling aircraft. How do you do this in this environment? You can't. So for God's sake, have the balls to say, I'm going to build the future of whatever. And, you know, I think it's hydrogen, I think it's whatever, but here is a program, a real program, 2,000 people for 10 years, getting it done. It's doable. It's, well, way better than what we're having today, but that's my problem. I think at the end, doesn't matter how much money governments spent on batteries, it helped a few startups, but the reality of battery came from the industry, came from the auto industry. Mm-hmm. And I think the same will happen to aviation. We need industry to be pushed hard enough to not be able to say, we're building yet another, you know, even bigger 777. That's nice, good for you, but what's next?
So maybe I'll sort of set it up for Sara to close us in a formal section and we'll take questions. But there is a fundamental question that I've been hearing a lot, that unless either Airbus or Boeing will do something, there is no way to change large aerospace. Reality is, as Howard said, there are now 260 sort of new airplane companies. Now, most of them won't succeed. That's just a reality. These two will. That, you know, just because I think they'll
now the pressure, you know.
No, it's like you can actually go and see the airplane, knock on it, right? The FAA, you know, pays attention. I think these programs are extremely advanced. I think the fundamental question: are we waiting for Airbus to Boeing? Or are we waiting for like the next aviation, next Joby, or aviation Joby to say, you know what, screw it, we're not waiting. We're just going to build the 50-seater and then the 250-seater and so on. Because the reality is, you know, it's not clear that the big companies are able to react. And with that small part, I mean, you used to have to go manage that conflict in one of these big companies. Can they react? Should they react? Is that even the waiting? You know, is that waiting for them even the right answer?
To use a phrase back when in a past life, when I was a management consultant and working with Microsoft, one of Berger's former companies, a big ship turns slowly, right? And so we can't expect the Boeing and the Airbuses to be the answer, but they can be strategic partners within the answer. And so when we talk about kind of the experimentation and the almost creative destruction that needs to have, when we think about how might we get to a decarbonized future, we are going to make, just industry generally, going to have to explore a lot of options, make the right bets. None of us know what the right answer is, despite how passionately we might argue about one thing or another. And not being an engineer is actually a freedom within aviation, because I don't become overly enamored with specific technologies. It's all about solving the problem, and how do we fall in love with the problem, and then how do we look at the resources within the industries. And when I think about Boeing and Airbus, great at certification, great at manufacturing, great at managing complex supply chains. I mean, there's issues here and there, but when you talk about the work of creating a new platform, it's one thing to design and prototype it and test it and fly it. It's a whole nother thing to certify it, and it is a whole nother thing to produce it at an affordable cost. Yep. And so then you need to, then that's when I think the Boeing and the Airbuses have a great role to play in being strategic partners to say, how do we actually get something into the market in a repeatable manner? And so, I think that's an important role for them to play in the industry, because they're not going to be able to make all the bets. When you look at the amount of R&D dollars they have and the amount of private capitals that's available out there that startups can take advantage of, like why would we ask Boeing and Airbus with their $2 billion to solve the future of the industry? That's silly. So I think the capital structures also play a really important role in where is innovation going to come from and what clock speed it's going to move at. So I think a lot of it is outside of the companies. So
interesting. Okay.
Yeah.
Time check. Thank you for the formal section, and if we have a few minutes, Howard will keep us on
Yeah,
clock.
Nick has a question from the
Actually,
audience.
go and take one from the audience if you can.
All right. We have questions from the audience.
And I've seen microphones in the middle of the table before.
Yeah, why don't we get microphones to people if there's a question? Yeah, no, it's for the online audience.
Yes. Oh,
Yeah, I
It's
think
on.
you're on.
You're good.
okay. Yeah. So going back to the question of operating costs, right? And question passenger miles. One way of reducing cost of operating Tesla is putting 4 passengers in the car, right? And so assumption is that with the future VTOL or a plane, they will be fully occupied or almost fully occupied, right? And so then you immediately impinge on the freedom of a person who maybe travel 5 miles to the airport, but then he has to wait 15 minutes for other 5, 10 passengers to arrive. So the question is, are we doing this calculation right? Are we, by assuming that there will be 10 passenger vehicles, is the right object for us to target at this point? Or maybe it should be single person, or maybe 2 people.
So in my view, there's going to be a mix of aircraft, and it really depends on the routes that you're flying. We've chosen a 4-passenger aircraft. It's a pilot and 4 passengers. We're targeting a 60% load factor, so a little over 2 passengers, aggregating a little over 2 passengers. We think that that's good for routes where there's high trip density. There are certainly opportunities on sparser routes for smaller aircraft, and there will be opportunities on thicker routes for larger aircraft. You see some of the other manufacturers out there that are targeting 7 and 9 seat aircraft, but I think you're thinking about it in exactly the right way.
But what numbers do you see right now in terms of operating costs for this mode of operation per passenger mile?
We've said we are going to be at $3 per passenger mile by 2026.
Okay, thank you.
At a 60% load factor. Yeah. And then, of course, you build a
For
9.
us, exactly. For us, it's very different because we, again, go into an existing business model. So depending on the operator and depending on the way he runs, most of our clients are scheduled operators. So they know their load factor. They are at around 60 to 70%. That's usually what happens in regional. And it's a scheduled service. So the passenger mile cost for a fixed wing aircraft is going to be dramatically lower. We're looking at many cents, but way under $1. That's probably true for anybody building electric, just because that's the way it works. And I think the question then becomes, does this open, and kind of reflecting on one of the comments Sara had, does this open the field for on-demand? Because today it doesn't really work. If you're not willing to pay a lot of money per mile, it's not going to be on demand. And the question is it on demand? And I don't like the on-demand headline, because if something is as frequent as 4 times an hour, that's on demand. Just go there. If something is kind of tailor-made for you, it really matters what it costs. So I think for a fixed aircraft and to do the matrix right, what you really care about is the kind of hourly direct operating cost. How much is it to fly this plane an hour? And we're seeing, I would say, anywhere between the mid $300 to just under $400 per flight hour, and we do roughly 200 to 250 miles nautical in that hour. So that's super cheap. The question is, really? I mean, how many people what's the real cost? How much is, insurance? How much is the pilot? How much was everything else? So it really depends how you answer this question. And it really depends, like with JoeBen's answer, it depends how far you fly and is it a high demand route? For us, it depends what kind of operator is operating it. Is it scheduled? Is it on demand? And why? But the base price is lower.
Maybe let me flip your question around. And for Sara, are there segments in the market in terms of costs and or load factors or ranges or aircraft classes that are missing?
It's a complex question.
Yeah. Like is the market producing the technology and the product that actually is necessary to solve all the customers' problem? I mean, do we need, like, is what we actually need is a single passenger aircraft, or like a segment that just isn't being addressed right now?
I think it depends on what market you're talking about. Are we talking about urban air mobility? Are we talking about regional? Are we talking about commercial aviation replacements? I think commercial aviation has kind of fine-tuned, what are the missions available and trying to, engineer to those specific missions. For me, we don't know what we don't know within, when we're talking about the urban setting. So I go back to, at the end of the day, it's about willingness to pay. And do we think that we can hit a target on operating costs that might be in the right range around willingness to pay? And then it also is a function of how big do you want the market to be? Because, even within commercial aviation, less than 20% of the world is flown on an aircraft. There's so much opportunity to expand that market, but it does go down to driving down operating costs further. And that is a function of the technology we have available. So I like JoeBen's statement about, we're trying to get costs as low as possible, because that really allows you to access more of the market. So, I'm more of a fan of creating for the masses as opposed to creating luxury products that, most people can't take. So it does, we should be trying to drive down operating costs, but again, function of technology.
Howard, do you have any time for more questions, or are we?
No, I think we're out.
We're out?
So
Okay.
thank you very much for the great panel and for the questions.
Thank you, guys.
Okay.
Thank you.
Thank you, guys.
Thanks.